2, we are going to be covering lesson 85, and this is finding polynomial roots, part 2. So I want to start with some problems on the sum of two cubes and the difference of two cubes. And so I'm going to write those rules down now. So the sum of two cubes, we have two terms that are cubed. And it's not always to the third power. It could be multiples of 3, so to the 6th, 9th, 12th. But it's two items that can be raised to the third power. So first things first, let's go over the pattern. So the factors would be a plus b, once you figure out what your terms are, times a squared minus a times b plus b squared. Now, a difference of two cubes is very similar. You have two terms, the difference between them, and our factors are almost identical except for the signs in between. So the first is a minus b, a squared plus ab plus b squared. So notice really the only difference is the first two signs. And there is an acronym to remember the signs, and that is SOAP. S-O-A-P. The first sign is the same. The next one is opposite. The last sign is always positive. Next, when they talk about roots, we're talking about x-intercepts or real solutions for x. And these solutions can be verified by Desmos. You would enter your polynomial and look for where your graph crosses the x-axis. So I'm going to do two with you, and then we'll do our lesson practice. So for all of these, we're going to find our roots. Find the roots for, and let's try number 1. Y equals x cubed minus 27. All right, now I noticed for here I have a subtraction sign, and I know that both of these are terms cubed. So this is a difference of two cubes. So I'm going to use this pattern, a minus b times a squared plus ab plus b squared. So the first thing I'm going to do is identify my first term cubed minus the second term cubed. So 3 cubed gives me 27. X cubed gives me x cubed. So my factors are x minus 3. So the first sign is the same as the problem. The next sign is going to be opposite, so the opposite of minus is plus, and the last is always positive. That's where this acronym, same, opposite, always positive, comes from. Now this should be your first term squared, so x squared. X times 3 is 3x, and this is b squared, which in this case is 3, so 9. Now, there are two ways to verify where my x-intercepts are. This one is easy. X minus 3 equals 0, so I would add 3. So x equals 3. This, however, if I check the discriminant, I bet it gives me imaginary solutions. So 3 squared minus 4 times a times c, that's 9 minus 36. That is going to give me negative 27, which would give me two complex roots. So my only real root is at x equals 3. Now we can confirm this. Let me pull up Desmos. I get a really bad glare, and that's the only problem. So y equals, and then I'm going to type in x and then a to the b, and that gives me third. And then down, whoops, and then minus 27. And notice the only place this graph, if you zoom in this way, and you can click on where it crosses, and it crosses at 3, 0. So that is the only place this graph crosses the x-axis, which is why this is the only root we are going to circle. So let's try our lesson practice. So it is on page 602. This is a long section, so I'm going to try to do a couple examples of each. So part A, they'd like us to find the roots of x cubed minus 8 equals 0. So again, I'm using that. This is a difference of two cubes, so I'm going to use these factors, a minus b, a squared plus a times b plus b squared. And I'm going to identify my terms cubed. So x cubed gives me x cubed, and 2 cubed gives me 8. So my factors are x minus 2, x squared plus 2x plus 4. So this gives me x equals a positive 2. This is 2 squared minus 4 times a times c. This is going to give me 4 minus 16, or negative 12. So again, this is going to give me two complex roots. So these will be imaginary. So my only real root is x equals 2, which can be confirmed by your graph. So notice I'm using discriminant to determine types of solutions. It'll also help me determine if I can factor it. All right, let's try lesson practice part B. Find the roots of x cubed plus 125 equals 0. All right, now this, because of this plus sign, is a sum of two cubes. And the only difference is our signs. The first is the same. Whoops. The next one is opposite, so a squared minus ab, and the last one is always positive. So this is x, right, cubed, plus the number here would be 5 cubed. So my factors are x plus 5, x squared minus 5x plus 25, because it's the 5 squared. So this first factor, if I set these equal to 0, x plus 5 equals 0. X would equal a negative 5. This, if I do the determinant, I get negative 5 squared minus 4 times 1 times 25. That would give me negative 75. So these are two imaginary roots. That's what this determinant means. So my only real root is x minus 5. So that takes care of those. We're going to move on to the next part of our notes, which is a review of, we're going to include the difference of two squares. So when we talk about squares, we're talking about two terms squared. So a squared minus b squared. My factors are real simple. One's a plus b, one's a minus b. So let's try an example. We're going to find the roots to x to the 6th minus 64 equals 0. All right, so we have to, I know my pattern is right here, but I have to identify what this first term is squared minus the next term squared. Now the 64 is easy, that's 8 squared. X to the 6th though, what is that squared? The easy solution is divide exponents. So 6 divided by 2 is x cubed. X cubed times x cubed is x to the 6th. So my factors are x cubed minus 8, x cubed plus 8. Whoa, now this can then be rewritten. Each of these is a sum of two cubes. And so I have, this is a difference of two cubes, so the factors here are x, this is what we just went over, x minus 2, x squared plus 2x plus 4. The factors here are x plus 2, x squared minus 2x plus 4. Sorry, my computer timed out. Give me 1 second. All right, so now this and this are both going to produce complex roots. So my only real solutions, if I set this equal to 0, I have x minus 2 equals 0 and x plus 2 equals 0. And we'll confirm this with Desmos. So my only two real roots are x equals 2 and negative 2. Again, this can be confirmed with where it crosses the x-axis on Desmos. So I'm just going to change my last. This is x to the 6th minus 64. And I'm going to go ahead and, zoom in. And I don't know if you can see my graph because there is a glare. And that is at 2. And this is at negative 2. So it can be confirmed using Desmos. All right, so let's try one more. X to the 9th plus 27 equals 0. Now, this one is a sum of two cubes, and I know that's hard to see. So I've got x cubed and 3 cubed. And so my factors would be x cubed plus 3, x to the 6th plus 3x cubed plus 9. So using Desmos, I would find the solution to this one, or just simply set it equal to 0. So x cubed plus 3 equals 0. So x cubed equals negative 3. Take the cube root. And using my calculator, the cube root of 3 gave me negative 1.44. Now, this one, this is all irrational or complex. So the only real one, this right here, is just all complex roots. And I can confirm that using Desmos. So like if you were to enter this equation into Desmos, the only place it crosses the x-axis is at negative 1.44. So back to our lesson practice, part C, x to the 9th minus 512 equals 0. So again, this is a difference of two cubes. This is x cubed, and this is 8 cubed. So my factors are x cubed minus 8, x to the 6th, remember because this is a squared, plus 8x cubed plus 64. So using Desmos, I'm going to enter this. X to the 9th minus 512. And the only place it crosses the x-axis is, guess what? At x equals 2. Part D, x to the 6th minus 729 equals 0. This is also a difference of two cubes. This third number, this is 9 cubed, and this is x squared cubed. So my factors are x squared minus 9, x to the 4th plus 9x plus 81. Whoops, 9x squared. So this is a difference of two squares, right? This is x squared minus 3 squared. So x minus 3 times x plus 3. I bet if I confirmed with Desmos, it crosses the x-axis at x equals 3 and negative 3. These are complex roots. All right, moving on to the rest. I think part E, you can use Desmos, but 5x cubed plus 2x minus 1. we're going to enter this into Desmos and see where it crosses the x-axis. So enter the equation into Desmos. So y equals 5x cubed plus 2x minus 1. And if I click on, I get x equals 0.372. So moving on in our notes, how to find roots using synthetic. So I'm going to do an example with you, and I think we are on example 4. So if I have x cubed plus 2x squared minus x minus 2 equals 0. So possible zeros are factors of my constant. So factors of 2 are just 1 and 2, divided by factors of my leading coefficient, which is 1. So my possible zeros are 1 over 1, which is 1, and 2 over 1, which is 2. So these are my possible zeros. I'm going to use synthetic to find a remainder of 0. And I'm going to use Desmos to confirm x-intercepts. So let's say I decide to start with synthetic because this problem's easy. I only have a few possible zeros. So I'm going to try positive 1. And I'm going to bring down my coefficients right here. So I have 1, 2, negative 1, negative 2. Bring down the first, multiply by the number out here. 1 times 1 is 1, add to come down. 3 times 1 is 3, add to come down. 2 times 1 is 2, add to come down, and I get a remainder of 0. So far I know that x equals positive 1 because it gave me a remainder of 0. Now I'm going to write my new polynomial, so 1x squared plus 3x plus 2, and I'm going to factor positive 2, positive 3, so my factors are 1 and 2, x plus 1, x plus 2. So now my two new solutions are negative 1 and negative 2. So here are all 3. Now, let's confirm this in Desmos because on a test I would want to see work, but you can confirm your answer on Desmos. So that is what I'm going to do. So x cubed plus 2x squared minus x minus 2. And if you look and you click, here's one solution at there's a major glare, at 1, 0, crosses the x at negative 1, 0, and crosses the x-axis at negative 2, 0. Look at your x values, negative 2, negative 1, and 1, right here. All right, next one. We're going to try one more. So if I want to solve 2x to the 4th minus 9x cubed plus 2x squared plus 9x minus 4 equals 0. So in this case, my possible zeros are factors of my constant. So factors of 4 are 1, 2, 4. Factors of my leading coefficient are 1 and 2. So my possible zeros equal 1 over 1, which is 1, 1 over 2, 2 over 1, 2 over 2, and 4 over 1. And any of them can be plus or minus. So I'm going to try positive 1 using my coefficients. I got 2, negative 9, 2, 9, and negative 4. So 2, negative 9, 2, 9, negative 4. Or I could check Desmos to see if positive 1 is even going to be a solution. So 2x to the 4th minus 9x cubed plus 2x squared plus 9x minus 4. Yep, if I look right there, it crosses at 0.5, positive 1. So I know positive 1 is going to work because it's an x-intercept on Desmos. So I'm going to bring down the 2. 1 times 2 is 2. Add to come down. 1 times negative 7. Add to come down. Negative 5 times 1. Add to come down. 4, 0. Now, according to Desmos, 0.5 is also a solution. So now I'm going to use synthetic with my new numbers for 0.5. Bring down the 2. Half of 2 is 1. Add to come down. Half of negative 6 is negative 3. Add to come down. Half of negative 8 is negative 4. So my new polynomial is 2x squared minus 6x minus 8. It has a GCF of 2, so x squared minus 3x minus 4. So I'm going to factor negative 4 and negative 3. That would give me negative 4 and positive 1. So x minus 4 and x plus 1. So let's record all 4 solutions. Okay? 1, 0.5, because both of those give me a remainder of 0. And then these two, 4 and negative 1. So those are my 4 solutions. 1, doesn't matter what order, 4, negative 1. So let's go back to our lesson practice, numbers F and G. So I'm going to have to actually turn the page. And let's see how F, G, H. Yeah, there's quite a few. We'll do F, G, and H. So part F. X, 4x cubed minus 4x squared plus 9x minus 9 equals 0. Now, you can find your possible zeros or use Desmos to find one x-intercept to start synthetic with. It's really up to you. And if you enter this polynomial, you'll find we should start with number 1. So I'm going to bring down my numbers for negative 4, positive 9, negative 9. Bring down the first number. 4 times 1 is 4. This gives me 0. 1 times 0 is 0. 9, 9, 0. My new polynomial is 4x squared plus 0x plus 9. And I'm going to go ahead and solve that. 4x squared plus 9 equals 0, right? Because I have no x terms. So that gives me 4x squared equals negative 9. This is going to produce imaginary. This is going to produce I. So my only real solution or root is this guy right here. Part G. X to the 4th minus 2x cubed minus 27x plus 54 equals 0. My possible zeros are all the factors of 54, but I'm going to use Desmos. Make sure you write a 0 for our missing term, and I'm going to pull up Desmos. So if I enter, I have x to the 4th. I'm just editing the last one, minus 2x cubed. Let's get rid of that one. Minus, let's change this to 27. And then this last part is plus 54. Oh, this should be 27. There we go. And I see that I have a nice 0 at positive 2. So bring down the 1, 2, 0, 0, 0, 0, negative 27, negative 54, 0. So I know x equals 2. This gives me 1x cubed. I have 0x squared, 0x minus 27. That's a difference of 2 cubes. So x minus 3, x squared plus 3x plus 9. So my other solution is positive 3. This would give me complex roots, and we discovered the same problem earlier. So the only real roots, even according to my graph on Desmos, is at 2, 0, and 3, 0. Okay, we'll do one more so that you're aware that sometimes we're going to have to use the quadratic formula. So 4x cubed plus 4x squared minus 29x plus 21 equals 0. So I'm going to always start with 1. So 4, 4, negative 29, 21. So bring down the first number. 4 times 1 is 4, 8, 8, negative 21, 0. So far I know that x equals 1 because I got a remainder of 0. Now I'm going to write my new polynomial. And I cannot factor this guy, or maybe I can. Maybe I don't want to factor this one because it's going to be miserable. So I'm going to use quadratic formula. So negative b plus or minus b squared minus 4 times a times c all over 2 times a. So let's simplify this. I get negative 8 plus or minus the square root all over 8. And I'm going to figure out what this is. What is 8 squared minus 4 times negative 21? And I get the square root of 400. And if I take the square root of 400, I get 20. So this is negative 8 plus or minus 20 over 8. So let's find our two solutions. Negative 8 plus 20 divided by 8. Negative 8 minus 20 divided by 8. So this gives me 1.5, and this gives me negative 3.5. So my solutions are x equals 1, x equals 1, x equals 1.5, x equals negative 3.5. And that completes. I'm going to skip part I. Thank you.